Hi CHEM245 students. Today we are going to do our third experiment, which is the recrystallization. To choose the best and adequate solvent for recrystallization, we are going to do some tests. The chemicals that we are going to use today are acetanilide, benzoic acid, anthracene, sodium benzoate, and stearic acid. The three different solvents that we are going to use are petroleum ether, acetone, and distilled water. To choose the adequate recrystallization solvent, we have to put a small amount of our chemical amount, and I will start to test the solubility of the 5 compounds inside water. So this is a small amount of my product with a small amount of my solvent. Now I have to put this test tube inside a water bath having the same temperature as the boiling point of the solvent. This time it's water, so the water bath is at 100 degrees C. Now I have prepared acetanilide. I will do the same for benzoic acid. A little amount of my solid, with a little amount of my liquid. The third compound is anthracene. Then little amount of my solvent. Now it's the turn of sodium benzoate. Little amount. With water. Then stearic acid. With water again. So first I have to test the solubility at cold. What should I do? I just have to shake well my test tube like this. I can see clearly that this stearic acid is not soluble inside water at room temperature because I still have too many crystals at the top of my liquid. I have prepared the solids inside the first solvent, which is water. I have to test their solubility at cold. Now this is acetanilide inside water at room temperature. If I shake well, I can still see the acetanilide crystals. So I can say that acetanilide is not soluble inside water at room temperature. Now I will check the solubility of benzoic acid inside water at room temperature. Now I can see that a big part of the solid I have added is dissolved. So I can say that benzoic acid is partially soluble, or its solubility is big inside water at room temperature. Now it's the turn of anthracene. Anthracene did not dissolve inside water at room temperature, and I can still see crystals. Sodium benzoate inside water, I see no crystals inside. So sodium benzoate is totally soluble inside water at room temperature. Stearic acid, big crystals are still inside the tube, so it's not soluble at cold. Now I have to go test the solubility at hot near the water bath of water that is at 100 degrees. We will start to test the solubility of the compounds at hot, at the boiling point of water, which is 100 degrees. Acetanilide did not dissolve at cold, that's why I have to check its solubility at hot. The water bath is at 100 degrees C, so the test should take a few seconds. I'm not allowed to leave the tube inside the water bath and go, because the solvent will directly evaporate. Now I'm seeing that acetanilide is going to dissolve totally at hot water, inside hot water. So I will see that the acetanilide will totally dissolve at hot water. Let me check. Also, benzoic acid has to be tested inside hot water because it not dissolved totally at room temperature. I will put it here like this. Now, as you will see, acetanilide has totally dissolved inside hot water. Now I will check benzoic acid. Also, benzoic acid has totally dissolved in hot water. Now I will check anthracene inside the boiling water. And as we saw that sodium benzoate has totally dissolved at cold, so there is no need to test it at hot. I will test stearic acid. I will put it here. So let me check anthracene. Anthracene seems not to be soluble at hot. I will leave it for more few seconds. Anthracene is not soluble in water even at hot. Stearic acid inside boiling water has formed a second layer at the top of the water. We have tested all our compounds inside water and we noted the results. Now we are going to test the solubility of the same 5 compounds, but this time using the solvent acetone. I'm going to start with the acetanilide inside acetone at cold. I see no more granules of acetanilide inside acetone at cold, so it is totally soluble at cold. This is benzoic acid inside acetone at cold. I see no more granules inside the tube, so I can say that benzoic acid is totally soluble inside acetone at cold. Now anthracene. If I shake well, I see no more anthracene inside acetone at cold. So for those three compounds, there is no need to do the hot test because the solute is already soluble at cold. I will test now the solubility of sodium benzoate inside acetone at cold. I still see the white granules, so I have to test the solubility at 62 degrees, which is the boiling point of acetone. I have to put it for a few seconds. Let me check the stearic acid at cold. I can still see granules of stearic acid inside acetone at cold, so I have to do the hot test. Let me check the sodium benzoate. As you see, I can still see this white trouble inside the acetone, so I can say that sodium benzoate is not soluble inside acetone even at hot temperature. Let me now check the stearic acid. The granules are about to disappear. There is no more granules inside the liquid. Now I can say that stearic acid is soluble inside acetone at hot temperature. We are done with the test with acetone. Now I'm next to the third water bath, which is at 50 degrees, which is the boiling point of petroleum ether. I will start to do the tests. Acetanilide inside petroleum ether at cold. I can still see the granules, the same amount as I have added at the bottom of my tube, so I will go to the hot test at 50 degrees. Let me wait few seconds. I can do the benzoic acid test at cold. The benzoic acid is still at the bottom of the tube at cold. So I will do the test at hot. Let me check the acetanilide at hot. It did not dissolve. So acetanilide is not soluble inside the petroleum ether at hot. Now I can check the benzoic acid. I can still see the granules of benzoic acid at the bottom of the tube, so benzoic acid is not soluble inside petroleum ether at hot. Now anthracene. Anthracene at cold. I can still see the granules. So it's not soluble at cold. I will check at hot. Sodium benzoate at cold is not soluble. Let me check it at hot. Anthracene did not dissolve at 50 degrees inside petroleum ether. Sodium benzoate did not dissolve, but let me check it again. It did not dissolve. Sodium benzoate did not dissolve even at hot. Stearic acid at cold petroleum ether, it's not soluble. Let me check at hot. Stearic acid has totally dissolved inside the petroleum ether at hot. There is no more crystals. Now we are done with our tests. We are going to move to the next part of our experiment, which is the recrystallization of acetanilide. Now after those tests, I can choose an adequate solvent to recrystallize acetanilide, and I will choose water. This is the second part of our experiment, which is the recrystallization of acetanilide. We weighed 1 gram of acetanilide. I have to put them in a glass beaker and to dissolve them with the little amount of hot boiling water. We have to add the minimum amount of water to let acetanilide dissolve completely when the water boils. As you see, there is some amount of insoluble impurity. That's why there is an utmost need to do a hot filtration to discard all those insoluble impurities, and this step should be very quick. Now waiting for the water to boil to make sure that I have dissolved all the amount of acetanilide. Those impurities are not soluble. I still have some granules of acetanilide. Now the water has started to boil. That's why I have to bring a hot funnel from the oven and put a small piece of cotton inside and do the hot filtration. This is the hot funnel. I have to put it here and put inside a small piece of cotton to hold the impurities on. Okay, I have to be a little bit quick to do the hot filtration. Now I can press this cotton to collect all the liquid to avoid losses. Now I am done with my hot filtration. I have to leave my compound to cool down and to collect acetanilide recrystallized While waiting for the crystals to form and to have a very nice shape, I will install the Buchner filter or the vacuum filter. I have to fix well my Erlenmeyer flask to avoid any damages. I hold it well with the iron clamp, then I fix the iron clamp on the support. Then I connect the funnel of the Erlenmeyer. I connect it to the vacuum. Like this. Okay, now I have to weigh a filter paper and know its weight exactly, which is 0.55 grams. I put it inside the funnel of the Buchner. I have to let it stick with little amount of the same solvent as my crystals, which is water. I have to let it fix well to have the vacuum inside later on when I turn it on. Now my Buchner filter is ready to do the filtration and to collect the crystals. I can leave my crystals to cool down at room temperature, or I can use some ice to cool it. Now I have to do the filtration. I open the water on to have vacuum inside my Erlenmeyer, and I have to get all the crystals on the filter paper. I can use little cold water . And now all my crystals are collected on the filter paper. I will leave it for more few seconds to let all the water go into the Erlenmeyer. To let the filter paper dry as much as possible. Now all the water is inside the Erlenmeyer flask. To stop the vacuum filtration, I have to disconnect the vacuum hose and turn the water off. I remove the funnel of the Buchner and try to get the filter paper with the crystals with a spatula. Okay. Now my solid is transferred here, and now I have to put my filter paper with the crystals inside the oven for a few time to let it dry completely to get the weight of the crystals. This is our oven. This is our wet compound on the filter paper. On the wet filter paper, I have to dry it inside the oven for some time at a lower temperature than its melting point, sure. So now the oven is at 68 degrees. After some time inside the oven, I have a dry filter paper with a dry compound which has the weight of 1.25 grams.